we'd be a little bit remiss if we didn't talk a little bit about radiometric dating. Um, Let me just emphasize that it's not a website for like single physicists. Okay. Okay, you didn't laugh at that. Okay. Here's the basic idea, right? If we want to determine the age of something using radioactive decay, there's two things we got to do, right? Three things, right? We got to somehow know the original proportion of unstable nuclei. We've got to somehow measure how much there is there very accurately, right? And then the final thing is that we're going to use this formula basically to calculate the time. In other words, we'll know how much we have now, how much we started with, right? And we know the decay probability of these things very accurately, right? So they're like little clocks. Radioactive decay is like a little clock, right? Let me give you an example of this, right? Carbon-14 dating. Basic idea is that the atmosphere contains some amount of carbon-14. It's created by radiation in the atmosphere. I think it has something to do with sunspots or something like that, right? Because they've got like a new method and an old method, right? But carbon-14 beta, let's see, carbon must be beta minusing to nitrogen, right? Okay, so is that right? Yeah, okay. And it's got a half-life of 5,730 years, right? And here's the deal: is that living things, all living organisms, you absorb it's like the carbon-14 is some of the carbon dioxide you're breathing right now has carbon-14 molecule as the carbon on CO2, right? And that becomes part of your body, right? And then of course when you die, you you stop absorbing carbon-14, right? Okay, and then the clock starts ticking, right? And then we measure the C14 ratio to C12, right? Old things don't have much carbon-12 left because it's decayed, and things that have just recently died have whatever very close to the current amount that's there, right? Okay, and I think you have to correct this for sunspot activity or something like that. Anyway, there are known corrections to it. So there's old dates and there's new dates for carbon-14. You can even date rocks, okay? And they determine the age of the Earth, I believe, by doing the dating, I think, between uranium decaying to lead, right? This has an exceedingly long half-life, right? Here's the idea, right, is that when rocks harden, they form little tiny crystals that are nearly pure, right? So you've got this, uranium atom, uranium atom, uranium atom. It's all uranium, right? It's like those houses on Harry Potter, wherever he lives, Privet Drive, right? They're all the same. Well, as time goes by, these things eventually decay out, right? It's like, ooh, that guy's turned into lead, right? So something that's really old has a lot of lead where there was once uranium, right? So you can just look at that. And the way the uranium gets in there is that, of course, the center of the Earth is this basically a very large fission reactor. That's what's keeping it hot, right? There's radioactive decay and radioactive elements there. Okay, so this is one of the most fascinating stories that has to do with radiometric dating. And I think it was Bill Bryson's book, A Brief History of Nearly Everything, where he talks about this, right? The fellow that determined the age of the Earth by using this dating method, right, was measuring the concentration of uranium versus lead, right? And I think there was a guy named Claire Patterson or something like that. You should look this up on Wikipedia. It's an amazing story, and I won't tell it very well. But basically, the idea was that he suddenly discovered that his samples he'd get these samples, and just carrying them back to the laboratory, they would get contaminated by being exposed to air. Well, air isn't supposed to have lead in it, right? But he's discovering all this lead because he's got this very sensitive apparatus for measuring lead concentrations. And he's discovering that air has a lot of lead in it. Where's the lead coming from? Well, back in the day, back in his day, we put lead, something called tetraethyl lead, in gasoline to prevent, to keep the valves working well and to keep it from knocking and stuff like that, right? I mean, there's a good idea. Let's put a known neurotoxin in gasoline, which we'll put it in the air when it burns, right? And so they actually went and looked at core samples. They looked at the ice in Greenland, and you can look at time, you can look at the air, and look at the lead concentration in air. Well, there's no lead in the air, because how do you get lead in the air, right? And then suddenly we invent cars and put lead in gasoline, and the concentration is just going boom, right? Well, lead is this very, very toxic thing. You can't have it in the air, eventually we're all going to be stupid, right? Lead, they think lead might have led to the demise of the Roman Empire, right? So the scientists, when they presented the evidence to the petroleum industry, right, the petroleum industry said, "Oh, that'll cost us a little money, but we'll take the lead out." Oh wait, that was an unintentional joke. But anyway, basically, no. They fought it. They said lead isn't a problem. The concentration is not rising. You can't make us take it out. I think it was like an act of Congress that forced them to do it. What they just should have done out of plain old decency. This same guy that detected the lead in the Earth's atmosphere, right, and saved us from all dying of stupidity, he actually invented the idea of a clean room, which is where you put on different clothes and everything is the air inside there is microfiltered, and the air inside the room is at a higher pressure, so it's always going out and stuff like that. He had to invent a clean room to keep lead off of his experiments, so that he could accurately measure the ratio of lead to uranium and determine the Earth's age, which is something like 4.55 billion years, which is an amazing story. Anyway, look that up. If you look up tetraethyl lead on Wikipedia, or if you look up, I think it's Claire Patterson, or Age of the Earth and Clean Room, which is a key thing. Anyway, yeah, enjoy.